Section 3 of Chapter 9 deals with stability, or rather the classification of stability. We're going to look at three different situations. First situation here, we've got a set of three pictures, and this is illustrating what is called stable equilibrium. In stable equilibrium, we have, first of all, equilibrium. So in this first picture, figure 911, we have the weight of the object pointing down. We have the normal force from the surface on which it's sitting pushing up. And those forces add up to zero. It's in equilibrium. The reason we classify this as stable equilibrium is because if we displace it a small amount, say we push this to the side, tip it a little bit, and then release that, it will return back to its original position. That's what we call stable equilibrium. We displace it a little bit from equilibrium, we let go of it, it returns to its equilibrium position. The third picture in this series is just showing that just because it's stable equilibrium does not mean it's stable for all displacements. If you give it a large enough displacement, you can remove it from equilibrium. In this case, cause it to tip over. Another way to illustrate this is with a ball sitting on different surfaces. In the case of stable equilibrium, we have a ball sitting in a well. Now, if we take that ball and we displace it away from equilibrium, and then we release it, it returns to its equilibrium position. And similar to the third picture in the previous series, if we displace it too far from equilibrium, it can roll away from its equilibrium position. But for small displacements away from equilibrium, if it is stable equilibrium, it will return to that center point, to that equilibrium point. Now let's take a look at another example. This is called unstable equilibrium. The characteristic of unstable equilibrium is, first of all, it's still in equilibrium. The forces add up to zero. There's no acceleration, so it is in equilibrium. But what makes it unstable is if we give it a small displacement, it never returns to its equilibrium position. It moves farther away from equilibrium in the direction we displaced it. In our ball example, here's a picture of a ball in equilibrium, but it's unstable equilibrium. If we give it a little push away from equilibrium, the ball rolls away, never returning. The third type of equilibrium is called neutral equilibrium. So again, we have equilibrium. Sum of the forces equals zero, there's no acceleration. But the characteristic that makes this neutral equilibrium is if we displace it a small amount away from this position, it neither returns to the original position nor travels farther away from the original position. This is called neutral equilibrium. Here is an example of a ball in neutral equilibrium. We displace it and it does not return, nor does it move farther away.